Hey everyone, welcome to another Manufacturing Live. And if you missed the one last week, last month, it was pretty awesome with Titans of CNC and John Milbury. They blew the doors off the numbers talking about manufacturing stuff. Today, we're going to take a little bit of a spin and we're going to talk about the future of our industry. And we're going to talk with some of the people that just went through Skills USA. And we actually have some people that placed pretty high. So I'm going to introduce the team from SEC. Everyone on the call on that side of the fence, please go ahead and introduce yourself. Let's start with Noah first.
Okay, I'm Noah. I did Skills USA, technical drafting, and I placed first at state, and then I got third at nationals.
Hi, I'm Olivia. I did the additive manufacturing competition at Skills USA, and I got second at state.
Hi, my name is Roberto Navas. I was Olivia's partner with additive manufacturing. I also got second at state.
Very cool. We need the teachers in the back. Who are you? Why are you here?
Go ahead.
I'm Josh Livengood. I'm an instructor in the Manufacturing Engineering Technology program in Milford, Nebraska. And I'm here just to support these guys. So.
And I am Lynnette Frey, also an instructor in the Manufacturing and Engineering Technology program in Milford. At Southeast Community College, we have to say.
we got to get all the titles in there before we start. Be official up front. So let's talk about Skills USA. So we got two that were a team in additive, one that was in technical drafting. Let's start with the additive group first. We'll save the third place national medal winner here. We'll put him to the second part. So let's talk about the additive process. Now, when I was out there, gosh, a few months ago now, I think, I don't know where the summer went, but you were all talking about the process you went through from designing the components and then everything you learned about additive. So let's start with the project that you created, and then we'll talk about the challenges that you had to overcome in the additive side of things.
So for us, there was a criteria that said we had to puzzle the judges while completing all the restrictions. So we came up with this design, and it is basically a maze that is encaged inside of a locking system that spins. It was quite challenging to get this to work correctly. First of all, because we had never experimented with, what do you call it, where you print everything together?
Oh, like assembly printing.
Yeah.
So
we're used to printing everything individually, and this was our first time experimenting with this, and thankfully it worked out for us.
Yeah. Originally, we were gonna do 3 locks on the outside, like that one that spins. We were gonna do 3. But due to printing time and material, we had to take our design down, and that took a lot of time to, try and figure out like what could make it still challenging for the judges yet fit all of the parameters. Because we were going to actually have a dummy lock on the outside to kind of play with them. So, yeah.
So can you bring that? Yeah, can you bring that up a little bit closer to the camera so they can see the locking mechanism? Because from a ways back, it just looks like a yellow part.
So this actually spins and it has letters. Our 3D printer didn't do a great job with the letters, but the actual one came out a lot nicer. And once you get it right, this whole thing comes up. Yeah, this whole thing like slides out, and then you're left with this maze right here. And then
yeah, and then on the inside, it held $10 in change. And we weren't sure of what kind of coins it was going to be or anything. They had half dollars, silver dollars, all different kinds. So.
Okay. So I'm going to ask a follow-up question here in a second, but one thing I forgot because I'm so excited to talk to students about this journey is this is a live session. So please, if you have questions or you want to know a little bit more about the process they went through or you want to add comments, please put them in the chat window and we'll go ahead and try to answer them. As always, as we were joking around before, hit like or subscribe so that way you can see more of these. I got to get, I get paid per like and subscribe, I guess, these days. So let's talk about tolerances because you talked about printing and assembly. What is it you learned about tolerances and stack up when it comes to additive?
So, well, we printed off some like sample parts to get the tolerances, but some of it didn't ring true because of the assembly. So we had to go through in the software to see the different layers as it was printing of where the support material was going to be and where the actual like part material is. And so that's kind of how we figured out our tolerances also.
I would like to add to that, the printers make a huge difference with tolerances, because we thought we were going to run into problems, but over there we actually found that our tolerances were right on, and we had like quite a bit of wiggle room compared to us messing around here with this.
Okay, so in what you just explained, you designed it at school, and you did some samples at school, and then when you went to the event, you printed them on completely different printers, right?
Yeah.
Yes.
Printed it live there?
Yeah, and that also changed the print time. So we actually had to email them and ask like what kind of printer they were using, because there was a 4-hour difference in the 3D printers print time.
Okay. How stressful was that?
Yeah, pretty stressful, but we got through it.
Yeah.
So I'm going to follow up with another question, because you guys are sort of skirting the challenge here. You're manufacturing engineering students. You take classes to learn about tolerances, stack up, analysis, assembly fit, tooling, fixture design. What did you take from this project? Because a lot of the things you go through are the same, whether it's subtractive manufacturing or additive. So what really did you learn about this process in how assemblies have to fit together to be successful? Because what you just described is what every manufacturing company goes through today in real life every single day. So how did this prepare you for that, and what takeaways did you get from it?
I'd say it helped me like really think more about how it's going to end up after it's all completed, like when it's done and printed and all the materials like dissolved and everything, and how it's going to function and how to make it function.
I believe I'm agreeing with her. I think it's called design intent. You want to picture the final result, and you want to design based off of that. This was a huge challenge for us because we were like learning as we went.
Which, I got news for you, that is the real world.
Yeah.
You're always learning as you go. But to me, those are the invaluable things. So my question is, would you do this whole process again with Skills USA? Do you think that other people should take this on and try it? Like, do you feel like you're better off for going through the stress and the printing and learning challenges?
Oh yeah, for sure. Yeah, it helped me like grow a lot. It was a big challenge, so it kind of put me out of my comfort zone, but it was fun.
Yeah, this really pushes you to what the real world has, because school can only teach you so much, and then you have to go out and actually be hands-on or experiment with it, and this is exactly what it did.
Okay. Did it change how you design parts?
I think for me, after completing this challenge, I am better at seeing the bigger picture and how to get there. Whereas before I tried to plan out every little thing, but it wouldn't work. So now I kind of switch my way of thinking, if you call it that.
Yep. Yeah, in the old salesy terms, we used to call that a paradigm shift, but we'll stay away from that old terminology. But so what I'm hearing is you're now looking at more of a design for manufacturability versus here's all the tool sets. I just want to make something cool and swoopy and lofty, and I really don't care what the outcome is.
I think the parameters and like the space it had to fit in, the design time, the print material, I think that really was a big factor in like really thinking harder and challenging us and how we're going to design it.
Did you change the print quality to adjust the tolerances, or how did you compensate for those? I know you said you ran tests, but there's a little bit more to it than I just ran a bunch of tests, because that's a long time to wait for a what if scenario.
Yeah. So on the bottom, we added some holes actually so that it would dissolve the print material quicker. And then also we took out some of the locks and also our design, like it looks like a padlock, but originally it was kind of going to be like a three, like it was going to have 3 little like spokes that went out, because it was just going to be based on the 3 locks that we had. So we obviously had to take out 2 of those locks. So that's kind of how we trimmed down the design time. And then we also, on our final design, this piece was actually this, because we figured out that once we get that out, we don't need like an extra piece in there. So.
Okay. So you went through several iterations of actually bringing a product to market, right? Like that's something that could be used in the real world as a locking game or mechanism for somebody.
Yeah. Mm-hmm.
Okay. What steps in those process did you like? Was it the figuring things out, or was it the actual manufacturing, holding it in your hand? Like what was the most gratifying piece of this for each of you?
I'd say like printing it out and then testing it to make sure that it works, because it was fun to see it like actually like in my hands and like something we designed that's working. So
okay.
Yeah, for me it has to be that working under pressure and that relief that comes after when you see that it works.
Yeah.
Okay, very cool. So we're going to go over to Noah now, and I'm going to pick on him a little bit about his experience with technical drafting. So Noah, explain to me what the project is that you did and the steps that you went through, and then I'm going to start interrogating you in the same way.
Okay, do you want the state or the national? Which one?
I want the national. You went for all the potato chips,
Okay.
so let's go for the big one.
So the national problem that we got was a electric motor design. So we had the stator, the commutator, the shaft that goes through, and then the 2 end caps with a couple bushings in them. So we got the problem at like 8 o'clock in the morning, and we had till 4:30 in the afternoon to produce all the parts, get all the assemblies done, everything like that, and then recreate the drawings back to what they wanted them to be.
Okay. So you get a package, you get a set of requirements. What's the stress and the pressure and all that good stuff like? Is it just you with your headphones on listening to whatever the pop music is of choice today, or?
So sadly, we can't listen to music, because then that would give us an edge to possibly talk to our advisors about the things, because everyone gets to see the problem, because they actually have a table out that has the problem laid out so people could walk by and look at what we're exactly doing. So no music, no internet, nothing like that. That would give us that would give each person an edge over the other person. So it's a lot of, you have to just listen to everything around you instead of listening to music.
Okay. So how did you approach this problem? Where did you start? Like, how did you break that down? What's your thought process as you go through this?
So my thought process was these 2 caps are pretty much the same other than a couple items. So if I build one, I can just change the dimensions on the other one and kind of fit it to be both of them. So that would cut down me modeling 2 parts into kind of a part and a half or a part and a quarter. Okay. And then a lot of it was just trying to first start out with some of the easier stuff and mix in, like do an easier part and then do a harder part and then do an easier part and kind of break it up that way. So I'm not just doing all the easy parts first and then getting to the hard parts and then being like, oh crap, I can't figure this out, but then kind of do a little bit of a mix of both. So if I get caught on something, I'll come back to it and do an easier part and then come back to it and fix the problem.
Okay. So as far as like the scoring and judging? Was it based on how cool you made the features and the product look, or was it like actually something that was judged based on if it were going to be produced in the real world? What would that be like?
So it was judged upon, they had a set of master prints, so how closely you could replicate the prints to that master print.
Okay, who made the prints? Was it like an industry standard thing that already existed and you just had to match it, or was it?
It was the head person that was running nationals. He actually sat down and found a motor in his garage, and a little tiny like DC little motor, and was like, well, why not make it? So he designed it himself.
Okay. So as you went through state and you went to nationals, what did you learn about yourself as far as competing and handling this kind of stress?
I learned how to manage my stress, or manage the stress of the job and kind of stuff like that, because at state I came in and I had to take a couple breathers because this is the first competition I actually was in for drafting and stuff like that. So I was really kind of jittery in a sense when it came to that. But then when it went to nationals, it was like, okay, this is my job. I have 8 hours. I need to get it done, and just kind of work at it at a consecutive pace instead of getting caught up with the stress and everything like that. And it's like, well, it's going to be there anyway, so why not just power through the stress and just get it done?
Okay. So you actually took it as a project management approach to this whole thing, right?
Yep.
Now, you're manufacturing engineering, like Noah and Roberto. What did this process drive you towards as it relates to, the manufacturing process, manufacturability? What did you like about it? What did it prepare you for when you go look for a job in the real world?
So it prepared me to kind of be given a project in the very beginning and kind of, well, figure it out in a sense. You have resources there, like the head person I was judging and like the head person there to kind of ask questions about it. But most of it's kind of, you're going to have to figure it out on your own, or you're going to have to figure out a way to fix whatever's going on there.
Okay. Something you like, I assume, since
Yep.
I heard that preparing, you were spending up to about 4 hours an evening on a CAD solution.
Yep.
Preparing for speed and accuracy. You don't have to look over your shoulder. I heard it from a birdie, but it might be one of those behind you that was talking about the dedication that all three of you went through. So we have a couple questions that have come in, and they are back on the 3D printing side. So Olivia and Roberto. So I got two. Noah, you can jump in too if you have any insight on this. I don't just want to pare it down to 2/3 and a third here, but the first question that came in was your product a design and 3D print only, or was there any machining after 3D printing?
So it was solely supposed to be 3D printing, because it's actually supposed to like bring out like additive manufacturing and be something that can only be 3D printed or manufactured by additive manufacturing. That's why we printed it as an assembly. Okay.
It's funny because that was the first question I had when I was out there on site, is like, if you're able to machine, because to me it's like you could rough out some really cool stuff in 3D print and come back and machine it. And you could adjust all your tolerances pretty darn easy.
Oh yeah. Yeah.
Versus have to account for the tolerances in printing. But the next question that comes in is, what were the material parameters for additive? Did you get to run calibration prints to identify optimum temps, layer heights, etc.?
No, we didn't get to run any of those temp tests. So
yeah, they weren't allowed to do the printing. That was all done by one of the judges. So
okay,
they kind of had to figure, and they weren't told. I don't think you guys were told the printing parameters, were you? You were just told what machine it was going to be printed on.
Let me check.
Yes, they have an engineering notebook too.
So it was
records. That's always a good thing.
We have it in here. I'm pretty sure it was like 3 cubic inches, or 6 cubic inches. Yeah. And there was 2 different ones for, like, one for the support material and then one for the actual printing material. So.
Okay. So a pretty generic starting point, which gives you as engineers a lot of opportunity to be engineers and figure it out along the way, right? Which to me, that's always the fun part, the figuring it out. So for Noah, do you have the medal? Do you all have medals? I want to see the medals.
Yeah.
Okay, so explain, you're holding up 2 of each. Explain a little bit. Let's start with Roberto. What are yours?
So the first one was 2nd place in additive manufacturing. And all 3 of us, plus another SEC student, got 2nd place, which we should have gone first, at the team building competition.
Technical team problem solving.
Technical team problem solving, yes.
I would like to add that we finished first and we completed the whole thing.
Okay. We're going to come back to that in a second because I wasn't aware of that award. So Olivia and Noah, I want you to share yours, and we're going to come back to that discussion.
Okay. So mine's for technical team problem solving, 2nd place as well, and then also the additive manufacturing, 2nd place.
Okay.
So this one here is for the gold for state for technical drafting. Then I have a silver for technical team building, and then I have my bronze for nationals.
Okay. Do you guys like wear those around campus just to flex on other students, or?
No.
I can hear Noah coming here.
Okay, so let's talk about technical team problem solving. Explain to me what that means, because in my world that means a lot of people yelling at each other on the shop floor. So please explain to me what that is.
So we were tasked to build a bridge that could hold as much weight as possible with popsicle sticks, and they're all different size popsicle sticks. And then we could only use, I think it was like 4 glue, three glue sticks,
yeah.
Like hot glue sticks. So
you couldn't like soak the popsicle sticks in glue to make them stronger to then put them together? Okay. So explain this process. How did you come up with the idea for your bridge? How did you know it was going to work? Who won on the ideation of this? Like, walk me through it.
I think it all started with another student that's not here right now. Her name is Mina. She has a lot of experience in the real world as like building houses and doing all the contractor side. And we were discussing some ideas, and she came up with the lattice idea, I think it was. Or she was trying to explain it, but we pinpointed that she was trying to say lattice, where the popsicle sticks just overlay on each other, and that was the base for our bridge. And then the walls were like triangle shapes, I believe.
Yep.
And we kept a little, like some sheets with some sketches, and we had to turn that in, and then we had to figure out a few.
We had to do like different views.
Yeah.
As a sketch, like top, front, side. Kind of like a mini engineering notebook, but it was just on the paper.
So how big is this bridge for reference? Like 3 feet long? And
so our parameters was it had to stretch over it had to span over 18 inches, but it could be no more than 24 inches long.
Okay. So
and then sorry.
No, go ahead.
They put a bread pan on it, and that's how they put the weight on top of it. So it also had to fit a bread pan on it with
5 inches or something.
So the weight was from the top. They didn't hang it from the bottom. So you didn't have to worry about like a mounting structure for hanging.
Mm-hmm.
Okay. So how much did it hold?
It held 60 pounds.
Yeah.
60 pounds. Okay.
And then they ran out of weight.
Yeah.
I mean, that's got to make you feel good, right?
Yeah.
Yeah.
So explain to me the whole finishing thing and that comment, because I want to dig into that a little bit because you finished it. So
allow me to take this one. We finished before every other group that was there.
think it was
Yeah.
We finished
I
before
think
the
it was like
timer was
Yeah,
5 minutes.
Yeah, it was
Yeah.
like 5 minutes left, and we took it up there, and they started just pouring weight on it, and we thought we secured first place.
Well, if it held all the weight they had and you were done first, how did you end up second?
That's what we don't know.
Yeah.
Well, I know they did have a like kind of aesthetic looks side of the competition. So I don't know. That must have been what it was. But
okay. So so they threw out the to be an engineer, you still have to make something that somebody would want to buy a piece, right? That was what got you.
yeah.
Okay. So what did you learn from this process? Explain to me how the collaboration, the building, the getting done, like, you know, interpreting someone's idea to actually build it. What did that teach you?
For me, it taught me that to never underestimate somebody like Mina, who really hasn't come from like an engineering side of things, coming from the real life experience and learning, hey, if they've probably done something similar to this, you should probably listen to them and get their input because they've done it before. They have had prior experience about it.
Okay. The other two, you don't get off. You guys have to answer too.
I'd say probably when someone has a good idea that sounds good, to go with it, because we also didn't have that much time to like go back and forth and say, well, this is another option, this is another option. We more have had to like pick one quick and just go with it.
Okay.
For me, I think we all learned how to delegate the jobs equally. I was on the glue gun, so they would pass me popsicle sticks, and we had an assembly line going. It was amazing.
Good.
Very cool. So for the guiding educators in the back, what did you learn from observing how all this went down?
It was, I have to say, it was one of my favorite things to be with these guys during the process of, especially Olivia and Roberto. I got to be involved and see their process of coming up with their design and then testing it on our 3D printer, and then being there when the time was ticking down and they had to turn in their project. We definitely had some real world issues, like, was it Roberto's computer that crashed?
It was mine.
Olivia's computer
It
crashed.
like, yeah.
When they had, I think, 30 minutes before they had to turn in their project. And so it's all of those real world things and that added layer of pressure that was really exciting. And I think we all have kind of a competitive spirit. And so just being a part of that was so exciting.
Okay. Josh?
I think the thing that got me the most was what they're capable of doing, you know. And, you know, I know that my students are always capable of doing a lot, you know. But when you just kind of, you know, see them go out of the nest a little bit and see what they can do, it's pretty neat.
So that brings me to the next topic that we're going to talk about. So along with school and Skills USA and all of these things, all three of you just completed an internship. And let's talk a little bit about that. And again, some of the people here have NDAs of the internships they worked in. So we're going to talk in generalities on some things. So please don't ask specific questions in the chat about a specific company, because they can't. We'll just leave it that way. But let's start with Noah. Let's talk about where you worked and what you did. And again, generalities, please, so we don't get in trouble.
So I worked for a medical company, and my summer internship, I was a drafting intern. So they had some older machines that they were not going to get rid of anytime soon, because the cost of getting a new machine in to replace it is way too much that they don't have money in the budget to do that. So I took all of their old legacy drawings of like 20 or 30-year-old machines, and I 3D modeled everything in Solidworks, put it all together in an assembly, and then redid all the 2D drawings from that.
Okay. So a lot of reverse engineering and reading between the lines on what's actually in the floor versus what's on the print.
Oh yeah. Yep.
Okay. What did you like about it? About that process?
I liked the whole aspect of kind of reverse engineering some of these machines that they had, because a couple of them they've done no modifying to machines that they've modified within the last year, and some of the records that they kept for the modifications weren't documented in general. So I had to go through and I'd take a print out to the floor and be like, okay, well, where is this on the machine? Because it's not on this, but it's on X, 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 Y, like all these other machines, but it's not on one of them. So then I would have to go through and make a note saying, okay, it's on this machine, but it's not on all of these other machines.
Okay. So did you like the detail oriented piece of that? Like the actual, like you're basically investigating how it works in the real world, right?
Oh yeah. Yep.
So the what I didn't know, Noah, is where you were located. I was actually out there about a month and a half ago, right next door to that company. If I'd have known that, I would have stopped and said hi. I spent a day out there in Broken Bow Land. So next time, if you're out there again, I will make sure to stop and say hi. Mm-hmm. Olivia, let's talk about your internship.
I worked for a landscaping company and designed some of their lights. So,
okay, so let's talk about that a little bit. Lights. Okay. Are we talking lights to land airplanes, or are we talking about
No. So they have these lights that actually portray the design that's cut out of the metal tube onto the ground. So they're really cool because depending on the design, it puts a different kind of pattern on the, some of them, they have them along paths. Some of them are mixed in with their landscaping and stuff like that.
Okay. So using design to portray art to mm-hmm. make it more visually pleasing to whatever mm-hmm. landscaping piece they're doing. Right. So yeah. Noah was more on the detail, investigation, documentation side. You were a little bit more on the, out of the form, fit, and function. You were more on the form side. So what did you like about that piece of it?
I really like to see how each design shows up on the ground, and I like the product, and I think it's pretty cool how they came up with it and everything.
Okay. Is there any cool lighting techniques that they're using these days, disco balls and things like that, or is it a lot more LEDs and dimmers?
Yeah, I think it's pretty cool how it portrays on the ground, but they just have the bulb in the top part. So
okay,
most of the light comes from the very top of the tube that goes in the ground.
Okay. So a lot of it is abstract thinking, right? Because you mm-hmm. have a tube and you have a light, and then you got to think about how that reflection is going to portray to create the shape you want.
Yeah, and they also have it on 4 sides of the tube. So you also got to think you can either have the design mirrored around it, or you can have it all going the same way. So you can think about how that's going to be portrayed then onto the ground as well.
Okay. So if we're thinking for the teachers and myself, where it's like the old Doc Brown, you're not thinking 4-dimensionally. You guys will have to go look that up if you haven't seen Back to the Future. But, you really have to think in that other realm of how this reflection is going to behave based on light, right?
Mm-hmm.
Okay. So we're going to go over to Roberto, and let's talk about your experience.
Okay. So this summer, I worked for a bullet manufacturing company in Grand Island. I was a machine operator most of the time. I spent some time with the engineers, and it was amazing seeing how they went back and forth.
And I've been out there, so I did the original training for Solidworks for that company way long time. They do some really cool things in terms of automation, right?
Oh yeah.
So talk a little bit about that without giving away details, but talk a little bit about the automation piece, because I think that's one of the things that makes them a little bit unique to be manufacturing at the capacity they do in the middle of Nebraska.
Okay, so I'll start off with what I saw and then go from there. So what I was doing was I was manufacturing cases, and I think they started off with just a few operations. But where I was working in, they turned it into a lot of operations. So you could do a lot more at once. And right behind me was actually a machine that took the copper wire or the brass wire and turned it into a full-on case, all in one, even washed it and everything. It was amazing to see.
And there's a lot of manufacturing challenges in that as far as how they draw it out and the dyes they use and all of that piece. Was that the part you worked with engineering on? Was some of those things to convert it, or which pieces of automation, again, without giving away all the details, but which pieces did you work on with them?
So when I was with the engineering, we worked on my side. So we had a big machine and there was around 15 operations, and it was a pain for the operator to get in there and switch out the dies. So to make it easier, instead of dropping the ejector guide, they tried to make a piece so you wouldn't have to do that, and it just make it a whole lot easier for the operator. I was also with engineering. Well, that same day, I was just bouncing between a lot of different people, and they were working on just anything you could think of, trying to make it better.
Very cool. So what did you like about your piece of your internship?
Just getting to learn the design and seeing how intricate, or just how different pieces go together. How they started off with just a few operations and turned it into where I was with around 15 different operations.
Okay. So you sort of like the collaboration and the goal seeking to improve the automation piece, right? More of the troubleshooting, problem solving. Okay. So let's go out to all three again, if we can zoom back out there. This is pretty high tech for us in Manufacturing Live. I mean, I know last month with Titans, we did, the 4 in the group with the big production, but so I have a question for all three of you. And the question is, after your internships in the 3 different experiences, which are very cool because they all fit in the realm of the manufacturing engineering process, what's your takeaway from it? Are you more energized to get done and go out in the real world and take on these challenges? Or is it more of, okay, I need to come back to school and I learned a few things. Now I want to explore something else and see where I want to go. So with that, since Noah was the first one last time, we'll go to Noah again, because it's been the longest since he's been on camera chatting. So what do you think after your internship and the program that you started with?
I'm really excited to go back into the workforce, to go back out into engineering and to do a lot of different stuff. It was really interesting because a lot of the stuff I learned out there is stuff that I haven't actually learned yet in class. And with like PLCs and fluid power and stuff like that my company uses a lot of that kind of stuff for their automation side of everything. So it's really interesting to kind of get how it actually works in the real world before kind of getting the lecture or the theory behind it. So now when I go back into my classes, into my theory, then I'll be like, okay, now I know why they did it this way, because this is how it works in theory, and being able to see how it actually works in real life and actually able to apply what I'm learning to real life.
Okay. Very good answer. Olivia?
I'm excited to go back in the real world and get in the workforce, but I'm also excited to go back to school, learn more. I mean, got a whole nother year of new stuff to learn, so.
Okay. Roberto?
I'm excited to go into the workforce again. I felt like school was all theoretical, but then once you got into the workforce, you started applying everything. And that's what I like doing. I like applying my knowledge into what I'm doing.
Okay. So one thing I sort of gathered from all three of you, and you can tell me I'm wrong, it's perfectly okay, but it seemed like all 3 of your internships had elements of not just sitting at the computer, actually going out and interacting with what it is you're designing, what it is you're building, the group that you're with. Is that the bigger draw and excitement for you going into the workforce, or is it more of, technology, software, the gadgets and gadgets piece? Roberto, you get to go first this time.
Okay. So, like you said, yeah, I do like being out on the floor. And I feel like with the company I was working in, I would see the engineers out on the floor a lot. So it was a lot of go out on the floor, take notes, see what's wrong, and then come back and try to fix it, and then go back out and see if you improved in any way. And that's really what I like, or what I would like to do right out of college.
Okay. Olivia?
Yeah, I like hands-on and computer like design work. I don't want to do like just design work because I mean, I like to go see like how it's going to work and function and what problems to solve after everything's designed.
Okay. Noah?
For me, I really liked when I was out on the line because I started talking kind of to the operators of the different lines I was working on, kind of getting the ins and outs of the machine and what works good and what doesn't work good, and just a general overview of like the sense of community. And everyone's like, oh yeah, we really like you being out here because then we can actually talk about the stuff. Then I'll go back and actually relay it to the engineers like, hey, did you know this is not working right, or this is working really well? And they'd be like, oh, okay, we'll look into it, and actually kind of be more of the middle person, which I really enjoyed doing also.
The good news for all of you is that is manufacturing engineering in a nutshell. So you picked the right type of engineering because, you know, that is generally that middle group that actually makes things happen, right? The people that are actually going to go and solve it. So kudos to all three of you. You didn't have a bad experience, but you brought up something, Noah, that is going to be my next question in this. And again, for anyone watching, you feel free to ask questions, and you know we'll get them answered the best we can. You all mentioned something that I think gets missed sometimes, and to be fair, it was the same thing when I was going through school, right? There's that generational shift. All three of you mentioned collaboration and communication. What is it from your perspective after doing internships that companies need to probably focus a little bit more on? Not that they're not doing, but what would be your recommendation to anyone if you have young people coming in? How do we do better as manufacturers to bring you in, keep you there, make you excited? Like, what are those things that are important to you for a company?
Being able to talk, again, like what I just said, being able to talk and communicate with your operators on the machines to figure out what works best for them and try to actually implement it instead of making, because if you make their lives better or easier, they're probably gonna put more out the door because their jobs are easier in a sense. And then it kind of comes full circle in the whole realm of things. And for companies to actually realize, hey, your operators aren't just numbers, they're actually people, and you should listen to them. And they have really, really valuable feedback on things that engineers you don't really see, because sometimes you're just going fire to fire to fire to putting them out. And you don't have time to sit down and actually see, or sit down for a day at a machine and be like, okay, what keeps breaking? What needs to be improved so it doesn't break as often, and stuff like that, for companies just to realize that.
Okay. In the company you were in, did they do like huddle meetings or daily meetings or like those type of catch up things of like, what fire do we have today? Or was it more like, hey, here's feedback we got from the shift from the night before. You know, we really think Bob's pretty cool. Let's hear what he has to say. Like, did any of those types of things go on?
Well, they usually at the beginning of the shift, they had kind of all the engineers would go kind of get in a huddle and, well, this is what happened last night. What are we going to fix today? Like, kind of, well, this is what happened last night, or this is what happened yesterday. We're going to go back and fix that today. It was more or less one of those kind of deals.
Was there ever a Bob involved? Because I love using Bob as a reference.
Yes.
So I just want to make sure. Okay, sweet. Bob's my go-to reference. So, Olivia, let's. I want to know what you think about this.
I'd say communication is key, like in any business, but I think just keeping communication open between like all departments of the whole engineering, design, production process is key also, because like you need to communicate with the other departments in order to know and like fix problems, just as Noah was saying. So.
So open communication, not
not like this is your department, this is your department. You guys have your own separate. Yeah, like everyone needs to be able to talk to each other and be on the same page.
Okay. Roberto?
I agree with exactly what Noah said. I know that there would be times where the engineer wouldn't listen to the operator necessarily, or they just wouldn't communicate at all, and then nothing would get done. But when I first got there, I took something apart, and me trying to be in the engineering brain, I went to a computer to look up the print, and I saw that what the print had and what I had were two completely different things. So I asked my supervisor about it, and he said, "Oh, those never get updated." And yeah, and that just kind of shocked me because I was thinking on how to do it myself when the print said a whole different thing. So I did need help from my supervisor to get it done. But yeah, better communication just makes everything flow smoother.
Okay. So what would you, assuming that the world was perfect, right? And we know it's not. If you had to give a message to companies that, let's say, think that they communicate well, but the experience of onboarding is different, like how would you determine going to work for a company? Let's not talk about internships. Let's talk about in general, right? You guys are going to go out and you're going to graduate. What are the most important things to you to find out from a potential employer to determine if it's a good fit for you? Because I can tell you firsthand, money is not the answer to everything, regardless of what celebrities tell you and YouTube stars tell you. How could you be reassured from a company that says, "Oh yeah, we have great culture, people love to work here, we communicate best"? How do you verify that to ensure you pick the right company to work for? What process in your mind is going to make someone feel good about that? Like make you good about going to work for them? Because there's a lot of companies that all have the 3 taglines and it sounds really good on the marketing brochure, but the reality is a little bit different. So what is the most important thing for you as you go out into the real world?
I'd say like the environment, like even through some of the tours we went to, you could just see by like the workers how they were feeling about their job, you know, if it was a positive or negative environment, and like how they get along with their coworkers and everything. You could just tell by their, you know, like moods as they're working.
Okay. That's a good one.
I'd probably say transparency in a sense from all lines of command, in a sense from like the highest person that you are at to like the lowest operator, kind of transparency, and everyone knows generally what's going on around the place, and not, oh, well, we're going to keep this secret because blah, 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 but letting everyone know of this is what's going to happen, and just transparency across the board is one of the biggest things I'd probably have to say.
Okay. Roberto?
I'd have to agree with both of them. I'd also say that a company having some type of incentive program to say, hey, you make our life better, we make yours better, whether that be like pay raise or just climbing the ranks, some type of program to help out the worker. That's what I'm looking for.
Okay. A long-term vision, right? Because it's a partnership.
Mm-hmm.
Okay. So Olivia sort of hit on something there, and I'm going to go back to it because everybody sort of said the same thing, but Olivia was the most straightforward with the answer she gave, and I want to pick on that a little bit in a good way. Don't take it as a bad way of picking. In previous manufacturing lives, we've talked a lot about manufacturing having an image issue. So there's 2 pieces to the question I'm going to ask, and I'm just going to ask it together so you can formulate an answer. Number 1, if you go into a manufacturing facility and it's dirty and dingy and, excuse my verbiage, a little bit of a shithole, does that does that set all of us in manufacturing back a little bit versus the ones that actually try to do better? And the follow-up to that is, what do you think us as manufacturers as a whole need to do better to bring more of your generation into the workforce? So anybody can go first, and I'm going to ask the teachers in the background too, so you guys don't get out of this, okay? Everybody's going to answer this question.
I believe that when people used to say manufacturing, they thought of some dingy, dark place full of oil and grease. And while some places might be like that, the world has changed. I know that a lot of places take pride in how clean their environment is. I know that, like where I work, yes, it was oily and greasy at times, but that isn't the case all the time. And I know that a lot of other manufacturing places are the exact opposite, where you can't have a speck of dust on the floor anymore.
Okay.
For me, making kind of the image that I've always heard kind of from my parents and just other people is manufacturing, you're going to be standing on a line on one machine for the rest of your life, pressing a button or doing one operation, like putting lug nuts on a tire or doing something like that. Just very repetitive work, which manufacturing is still kind of that way, but with automation, it's changed a lot of things. Because instead of being overseeing like one machine, you're overseeing a couple of different machines that are automized or that have automation put on them. And you're kind of overseeing all of it instead of just sitting there putting like lug nuts on a tire and stuff like that. So
funny reference with that lug nut on a tire. You can make a 6-figure income right now putting lug nuts on a tire on an assembly line at an automotive. So you picked a really good reference, and it brings home a really good point of those people still work in a very clean environment, but the image is that's a mundane job. That person, however, is making 6 figures a year doing that job. Could we do it with robotics and use that person's mind for something better? Absolutely. But it is funny you mentioned that as a reference of an image, because we all assume it's like the old school days, not that person like being able to support his family or his or her family doing that one job. So good reference, my friend. That was a good one to call out. Olivia, let's go to you, and then we're going to go to the teachers.
I'd say a lot of times when I talk, like say what I'm going into, people are like, oh, you're going to, like Noah said, you're just going to stay in the same place, like production all the time, doing the same thing. Or I hear, oh, you're just, replacing more people's jobs with robots. It's like, well, no, we're making everything more efficient and making everything better. And like everything has to be made somehow. So it's like everything anyone uses has to be made through manufacturing. So.
And so before we go to the educators, what do you think needs to be done different to change that persona? Because it's too late for us older people, but for your generation, we have a chance to change the narrative. So if you had a magic wand to change it, how would you change that image to get away from the social media blame game type thing where it's like, oh, you're just going to replace people's jobs? Never mind that there isn't anybody to do those jobs, but you're going to replace them. Like, how would you spin that change? Or TikTok?
I was gonna say try to promote more robotics, or try to educate more people into robotics. I know we do when we do the job fair. No, the
manufacturing day.
Yeah, it's all about promoting robotics in the future, and I think educating people in what the future has to offer would inspire the next generation into joining the manufacturing workforce.
Okay. Anybody else want to add to that, or?
I'd say like people need to realize that like robots aren't necessarily like they're not terrible. Like they're helping the production line. They're not, completely replacing people's jobs. They're just helping.
Yeah. And I'd even add on that is like in like a production standpoint. If I get a robot, I'm going to hire someone that can run that robot. Like, I'm not just going to be like, oh, well, I'm replacing a robot on a process, so I'm just replacing them with a human with a robot. Well, you have to have someone be able to program that robot, be able to maintain that robot, be able to do all the stuff to the robot. So instead of like getting rid of that one person, you may be getting 2 to 3 people, but they're overseeing 3 robots instead of just one. So you have those 2 to 3 people just allocated to more of their time being, okay, let's do like quality control. Let's do more of the other jobs in a sense, and not just standing on the line doing the same item every single day.
Which often comes with a higher pay scale and a better quality of life for the human that's doing it.
Yep.
Right. So we'll end with this question, but I want the comments from the educators. You guys don't get out of this. So let's go with you, Josh. You get to start first.
So, creativity, I think, in manufacturing is a big deal. And I think that, encouraging creativity in the workers and is a really good way to get that dunginess of manufacturing out. There's some auto manufacturers in Europe who are, they have it's like a park when you go in there and work. There's trees and it's just really pretty. There's skylight. They have skylights opened up. And I think allowing the manufacturing engineers and just to use their creativity in the work environments is going to be a huge step to changing the face of manufacturing. But the technology like these guys are talking about too with robots. I mean, how fun is it to work on robots? And PLCs and I always thought it was exciting and it always appealed to me to do that kinds of stuff. So yeah.
Yeah, I agree with what everybody's saying. I think that we need to do a better job of educating future students that this really is a high-tech field, and even though you may spend some of your time out on the floor problem solving, the floor is clean, and the employers now are really taking care of their people, and it may be climate controlled. We've gone on a lot of tours where the floors are just beautiful, it's well lit, and it's climate controlled so that it's comfortable in that setting. And so now again we're focusing more on the high tech part of it, whether it's programming robots or building in some automation into some of those machines. And the students get to do all kinds of things. We were talking in our workforce leadership team about how do we explain what it is that they're doing, because you were at that meeting, and some of those all of the job titles that a manufacturing engineer would have, and that one day they may be a crime scene investigator, or the next day, they're a designer. And so kind of figuring out a way to explain that to future students in our program, that they're kind of like a project manager of a manufacturing process, really. And I think more people understand what a project manager does, like in the construction field. So, relating it to something that they know, and then just getting students out into some of those manufacturing facilities and highlighting some of the really cool stuff that we make in Nebraska. Whether it's, airplane parts or medical parts, all of the cool things that we manufacture here.
Yeah, there's a lot of hidden stuff in Nebraska. That is for sure. We're coming up on the end of the hour, so there's a couple things we gotta throw in here, right? This team is going to be out at Husker Harvest Days coming up, right? For the people that aren't cool and don't know what Husker Harvest Days is, Husker Harvest Days is a very huge, very large farm show that happens every fall in Nebraska. I'm bummed because it's at the same time as IMTS, which I will be there instead of Husker Harvest Days. My days working at Heston, that was always the big year. You go out and all the manufacturers compete and show off their prototype stuff. And, it's a big showcase. Lynnette and Josh, we were talking a little bit about before, they're going to have a big SCC booth. These students will be there as well. We'll be talking about manufacturing. So if you happen to find nothing to do opposite of IMTS, please go check them out at Husker Harvest Days coming up here in a few weeks. This team also has an Instagram page. Lynnette, can you tell us what that page is?
It's Manufacturing Engineering Tech, and I basically just highlight the students and some of their projects. So it's really fun. I think that hopefully it helps to communicate how much fun we have, right?
There's some really cool projects. I try to stop out when I go by every so often. They're always doing something really cool. The last thing is our next manufacturing live that's going to be coming up will be a highlight show from IMTS. Dassault, Solidworks, we're going to have 2 booths at IMTS. So please come find us, check out some new things. We'll be showcasing a few cool things with factory automation, factory flow, robotics that we've talked about heavily here. We're going to be talking about, integrating some of the CAD, CAM, simulation pieces all in our booth. And I think we might actually have a robot live in one of the booths. It's right now where it'll either be AR, VR headset or a robot in the booth that we're going to go over. And as always, please like and subscribe because, again, I got to say it twice, one at the beginning, one at the end, so we don't forget. But with that, I can't thank you all enough for being part of this. You all 3 of you are amazing students that are doing awesome things, and I cannot wait to go visit you when you're with customers in the future. So thank you so much. And with that, we're going to call it a day. Check us out next month. Okay, we're good. Thank you all. That was amazing.